We'll look now at equations of motion. So these apply whenever acceleration is constant. Okay, so this is, it's not going to apply whenever something is accelerating and then it's decelerating and then accelerating again. Each bit of motion, maybe you could apply an equation of motion, but the acceleration has to be constant. So your four equations, v equals u plus at, v squared equals u squared plus 2as, s equals ut plus a half at squared, and s equals a half upon u plus v times t. U then stands for the initial velocity, and that's in meters per second. V then is the final velocity, and that's again in meters per second. A is the acceleration, and that's meters per second squared. S is displacement, and it's in meters, and T is time, and it's in seconds. Now, you will sometimes see in questions, instead of velocity, they'll say speed. That's fine. And sometimes instead of displacement, they'll say distance. Again, that's okay. Example 1 then. We're going to look first of all at horizontal motion, and we'll get on later in the course to look at vertical motion, something being dropped from a building or thrown up. So a body is moving at velocity of 3 meters per second, and it accelerates uniformly at 2 meters per second for 5 seconds. Find its final velocity. So get into the habit of writing down u, v, a, s, t, and putting in what we know for this part of the motion. So it starts at 3 meters per second, and then it accelerates at 2 meters per second squared, and it's for 5 seconds. And we want the final velocity, so that's v. So we don't know anything about s, and we don't have the value for s, so we can forget about it. So we want an equation that will link a, v, u, and t then. So v equals u plus at. Now sometimes there's more than one equation that you use, sometimes there's only one that you can use, but if there's more than one, it doesn't matter which one you pick. So put in our values. U is 3, a is 2, t is 5, so that's 3 plus 10. So we have 13 meters per second. Part 2 then, the distance it covers. Again, u, v, a, s, t. So our u is 3. Our v we found out was 13. Our acceleration was 2. We don't know s, that's what we're trying to find out. And the time is 5. Now, there's a couple of equations we could use here. I'm going to use s equals ut plus a half at squared. Now, you could also use s equals a half upon u plus v times t. I've decided not to use that because the v is the one I've calculated myself in part 1. So just in case I made a mistake, I'm not going to use this one here. I'm going to use the s equals ut plus a half at squared. So 3 times 5 plus a half times 2 times 5 squared, that's 25. So we have 15 plus 25, which is 40, and s is distance, so that's in meters. Example 2 then, a body reaches a velocity of 24 meters per second after accelerating uniformly for 8 seconds, during which time it travels 112 meters. Find, first of all, its initial velocity. So u, v, a, s, t. So we're trying to find its initial velocity. That's what we're looking for. V, we've got its final velocity. It reaches 24 meters per second. in 8 seconds goes over 112 meters. So we want a formula that connects V, U, S, and T. Okay, so if S equals 1/2 upon U plus V times T. So get in the habit of writing out the formula that you're using, make it very clear that you know what you're doing. Put in all the values that we know. And this is what we'll have. So I'm going to say 1/2 times 8 is 4. So then I'm going to divide by 4. Get just U plus 24 on this side. So 112 divided by 4 gives us 28. So bring the plus 24 across, and it'll be 28 minus 24 is U. So U is 4 meters per second. And always make sure that your answer makes sense. If something is accelerating up to a velocity of 24, then you'd expect your initial velocity to be less than 24. So if you did something silly and you brought like the plus 24 over and kept it as plus 24, you'd have an answer greater than 24 then, so you would know that you've gone wrong. So make sure, like, these are practical questions that would happen in real life. So it's make sure that your answer makes sense. Part 2 then, we're looking for its acceleration. So again, U, V, A, S, T. So U we found now is 4. V we were told was 24. S 112. And T 8. And we're looking for the acceleration. Again, you can use different formulas. I'm going to use V equals U plus AT. So that's 24 equals 4 plus A times 8, so 8A. So I'm going to bring our 4 over and have 20 equals 8A, and then divide 20 by 8, and I get that A is 2.5 meters per second squared. Example 3, a body traveling at 4 meters per second comes to rest uniformly in 1.6 seconds. Find its deceleration. So again, let's start U, V, A, S, T. So it starts at 4 meters per second. So that's its initial velocity. It comes to rest. That means it stops. So V is 0. And that's 1.6 seconds. Now we've got no letter for deceleration. So we're going to have to find the acceleration, and then I'll show you how the two are related then. So if we have V equals U plus AT, I have 0 equals 4 plus 1.6A. Bring my 4 over, I get minus 4 equals 1.6A, and then I'm going to divide minus 4 by 1.6, and we get minus 2.5 meters per second squared. And you'd expect a negative acceleration because it's slowing down. But that's the acceleration. The question asks you for the deceleration. So we say the deceleration is 2.5 meters per second squared. The D bit in it implies that it's negative acceleration. Okay, so if you have an acceleration of minus 2.5, your deceleration is 2.5 meters per second squared. And part 2 then, the distance travelled, again, U, V, A, S, T. So our initial speed was 4. It slowed to rest, so our final velocity there is 0. It took 1.6 seconds. And we find the acceleration is minus 2.5 meters per second squared. And we're looking for S. So again, there's more than one formula you could use. I'm going to use this one here. S equals 1/2 upon U plus V times T. So that's 1/2 upon 4 plus nothing times 1.6. So 4 plus nothing is obviously 4. So multiply those together and we get 3.2 meters. Just a wee note on units then. So meters per second can also be written as ms to the -1. And as far as I can remember, people who do physics will tend to write it like that. So acceleration, meters per second squared, can be written as ms to -2. Both of those units are acceptable. And the only other really thing we use then is changing. So say we have 2.5 kilometers per hour and we want to change that into meters per second. Well, we're going to multiply by 1,000, and that would be meters per hour. And then to get it to be meters per second, well, we'd have to divide by 60 to get meters per minute, and divide by 60 again to get meters per second. So that's the same as dividing by 3,600, and that will put it into meters per second. So that gives us 0.694 meters per second. Okay, so that's a very common change that you have to do from kilometers per hour into meters per second.